Hello dear students, in this particular lecture we are going to discuss the algebra of derivatives and the theorems of derivatives such as sum rule, product rule, quotient rule and difference rule of derivatives. And we will also look at their proofs along with some examples based on them. So let's get started. We have to find the derivative of fx equals to x square. So we can again use first principle. Here fx is given to be equal to x square. So f of x plus h becomes equal to x plus h whole square. Let us write down the derivative. F dash x in terms of limit is given to be limit h tending to 0 f of x plus h minus f of x divided by h. Alright, according to the first principle of derivatives. So this can be written as limit h tending to 0 f of x plus h becomes x plus h whole square minus f of x is x square whole divided by h. Now we can use the identity of a square minus b square. So we can write it down as limit h tending to 0 a square minus b square is a plus b multiplied by a minus b, and this is divided by h. So this is equal to limit h tending to 0. Over here we get 2x plus h, and over here x minus x get cancelled off and we have h divided by h. Now because of this h, indeterminacy was 0 by 0, but since h is approaching to 0, we can cancel them off in numerator and denominator. Now this limit is nothing but equal to 2x because x is independent of h and h approaches to 0, this is equal to 0. So limit simply comes out to be 2x, and this is the derivative of x square with respect to x. So dy by dx for y is equal to x square comes out to be equal to 2x, or we can write d by dx of x square to be equal to 2x. Alright students, so these are very simpler type of problems which are based on first principle, and you can apply first principle in order to determine the derivative of any function which is in standard form. Now let's understand some theorems which are very important and will be highly used in 12th classes while determining the derivatives of functions which are combination of various functions. So the theorem says let f and g be two functions such that their derivatives are defined in a common domain. Then derivative of sum of two functions is sum of the derivative of the functions, which means that if we have a function f of x and g of x, and if we have another function which is addition of these two functions, then derivative of that function will be the sum of derivative of individual functions. For example, if we have fx as sin x and gx as x square, and if we have another function hx as sin x plus x square, then derivative of hx with respect to x will be equal to derivative of sin x with respect to x plus derivative of x square with respect to x. And derivative of sin x is known to us, this is equal to cos x, and derivative of x square is equal to 2x. So derivative of this function with respect to x becomes simply equal to cos x plus 2x according to first part of the theorem. I hope everybody must have understood. Second statement says derivative of difference of two functions is difference of derivatives of two functions. So again let me illustrate by the same example. If we have fx as sin x and gx as x square, and now if I introduce a function hx which is difference of given two function, so derivative of hx with respect to x can be written as derivative of sin x minus derivative of x square, because hx is equal to sin x minus x square, difference of given two functions, and d by dx of sin x will be cos x and d by dx of x square is equal to 2x. So simply derivative of hx with respect to x comes out to be cos x minus 2x. Alright students, these two theorems are very obvious that the derivative of sum of two function is equal to the sum of derivative of two functions, or derivative of difference of two functions is equal to the difference of derivatives of two functions. Let's move further to see third part of this theorem. Now derivative of product of two functions, please make a note, it is not equal to the product of derivative of two functions, but it is written in this way: d by dx of fx into gx is d by dx of fx multiplied by gx plus d by dx of gx multiplied by fx. Now if I consider that fx is equal to u and gx is equal to v, so if we were to calculate the d by dx of product of these two functions, then this is simply equal to du by dx multiplied by v plus dv by dx multiplied by u, and this can also be written as uv whole dash is equal to u dash v plus v dash u. Alright, you must also be comfortable in understanding it in this way: uv dash represent derivative of product of uv function, and u dash represent differentiation of u with respect to x, and v dash represents differentiation of v with respect to x. So uv dash is equal to u dash v plus v dash u. So this is the product rule of derivative of two functions. Similarly, we have another rule which is known as the quotient rule. So derivative of quotient of two functions where denominator is non-zero is given by if the functions are f of x and g of x. So f of x divided by g of x has its derivative as derivative of fx multiplied by gx minus derivative of gx multiplied by fx whole divided by gx का स्क्वायर. चलिए कंसिडर करते हैं कि fx is equal to u and gx is equal to v. So d by dx of u by v is given by v square in the denominator. Then over here we will have v multiplied by du by dx minus u multiplied by dv by dx. And now in terms of dash, this becomes u by v dash, and this is equal to v u dash minus u into v dash whole divided by v square. Alright students, I hope you are able to understand the product rule of differentiation and quotient rule of derivatives or differentiation. Now the first two, that is the sum and difference of derivatives, was easier to understand, and the third and fourth we are going to prove them. So now let us prove the product rule and the quotient rule one by one. Let us start with product rule. So in product rule, as we have already discussed, we have a function f of x as u and another function g of x as v, and we have defined another function w which is product of these two functions, that is f of x and g of x. So now let us consider a new function p of x which is product of these two functions f of x and g of x. So we are interested in finding the derivative of p of x with respect to x, which is equal to p dash x. And by first principle, in terms of limit, we can write it down as limit h tending to 0 p of x plus h minus p of x whole divided by h. So this is equal to limit h tending to 0 p of x plus h means we will have to replace over here and also over here x with x plus h. So this becomes f of x plus h into g of x plus h minus p of x is simply f of x into g of x divided by h. Now what we are going to do is we are simply going to add one term and subtract that same term such that the expression remains unchanged. So we are going to write down minus of f of x into g of x plus h plus f of x into g of x plus h. I have added this term and also subtracted this term, which means I have not changed this expression. And further we have minus f of x into g of x whole divided by h. I hope everybody understands what change I have made to this expression. We have added some quantity and also we have subtracted the same quantity so that the expression is unchanged. Now from these two terms we can have g of x plus h as common. So we are left with limit h tending to 0, g of x plus h, f of x plus h minus f of x, and further from these two terms we are going to get f of x as common, and we are left with g of x plus h minus g of x whole divided by h. Alright students, so now we can write it down in this way: limit h tending to 0, g of x plus h, f of x plus h minus f of x divided by h, plus limit h tending to 0, f of x multiplied by g of x plus h minus g of x divided by h. I hope everybody understands that we have separated the limits, and now this expression is familiar to us. F of x plus h minus fx divided by h becomes f dash x upon applying the limit, and this is equal to g of x since h approaches to 0. So this part becomes equal to g of x multiplied by f dash x, and over here this part becomes what? G dash x multiplied by fx. Hence proved that derivative of the function which is product of two functions, that is f of x into g of x, is nothing but equal to f dash x into gx plus g dash x into fx. So we have proved the product rule using first principle. I hope everybody is able to understand till here. Now let us prove quotient rule using first principle of derivative. So consider that we have a function f of x and another function g of x, and now we have introduced another function which is p of x, and p of x is quotient of these two functions f of x divided by g of x, such that g of x is non-zero, so that this function is well defined. So quotient rule says that p dash x will be given by g of x square in the denominator and then g of x into f dash x minus f of x into g dash x. This is what product rule says. So we are going to prove it. So p dash x according to the first principle of derivative can be written as limit h tending to 0, p of x plus h minus p of x whole divided by h. Now this becomes equal to limit h tending to 0. P of x plus h means over here and also over here we will have to replace x with x plus h. So this becomes f of x plus h divided by g of x plus h minus p of x is given to us as f of x divided by g of x, and this is whole divided by h. Alright, so this can further be written as limit h tending to 0, g of x into f of x plus h minus f of x into g of x plus h whole divided by h into g of x into g of x plus h. Upon taking LCM in numerator, we can convert it into this form. Alright, so now again in the numerator, in order to arrive to this result, we have gx along with f dash x, but here we have f of x plus h, and f dash x can be created when we have f of x plus h minus fx divided by h. So what we are going to do? We are again going to add something and subtract that same quantity so that the expression is unchanged. So we have gx into f of x plus h, and now subtract f of x into g of x, and I am going to add the same f of x into g of x, and then we have minus f of x into g of x plus h, and this is whole divided by h into g of x into g of x plus h. I hope everybody understands what we have done. In this expression in the numerator over here, we have subtracted fx into gx and we have added fx into gx so that the expression remains unchanged, and this term is written over here and this term is written over here, and denominator is as it is. Alright students, so now from these two terms we can have g of x as common, and from these two terms we can have f of x as common. So let's take common. So limit h tending to 0, this becomes g of x multiplied by f of x plus h minus f of x, plus on taking f of x common from these two terms, we are left with g of x minus g of x plus h, and this is whole divided by h into g of x into g of x plus h. Now we are going to separate the limits, so we can write limit h tending to 0, g of x multiplied by f of x plus h minus f of x whole divided by h into g of x into g of x plus h minus limit h tends to 0, f of x into g of x plus h minus g of x whole divided by h into g of x into g of x plus h. Alright students, now observe carefully that this f of x plus h minus f of x divided by h becomes f dash x when limit h is approaching to 0, and this expression over here, that is g of x plus h minus gx divided by h when limit h approaches to 0, this also becomes equal to what? G dash x. Alright, and fx, gx, gx, these are independent of the limit because limit is being applied on h, and g of x plus h is simply g of x, and over here also this is simply g of x. So I think we are done. After applying the limits, over here we get g of x, and this becomes f dash x divided by g of x into g of x, which is g of x whole square, minus over here we have fx multiplied by g dash x divided by g of x into g of x, again g of x whole square. Now you are just required to take the LCM. So in denominator we have g of x square, and in numerator we have g of x into f dash x minus f of x into g dash x, and this is what we have written over here as result. So hence proved that quotient rule is equal to this quantity. So now let us discuss a couple of questions which are very basic in nature and which are based on what we have studied so far. So question says, find the derivative of first part f of x is equal to this function, and second f of x is equal to this function. So we have to find the derivative of these two functions one by one. So let's begin with the solution part. One can easily observe that over here we have quotient of two functions x plus cos x and tan x. So definitely we are going to use quotient rule in order to determine the derivative of f of x. Alright students, so we have been given f of x as x plus cos x divided by tan x. So f dash x is equal to, in quotient rule we do square of the denominator. So in denominator we are going to have tan x square, and in numerator we are going to write denominator function as it is, that is tan x, multiplied by derivative of the numerator, which is x plus cos x dash. Dash means the derivative of that function with respect to x, minus, now the numerator function is to be written as it is, x plus cos x, multiplied by derivative of the function in denominator, which is represented by tan x dash. Again, dash implies derivative of tan x with respect to x. Alright, so far we have just applied the formula of quotient rule. Now let's do the derivative. We have tan x multiplied by, over here we have two functions, in fact sum of two functions, so we are going to use sum rule. So this becomes derivative of x plus derivative of cos x. Derivative of x is simply 1 and derivative of cos x is going to be minus sin x, minus x plus cos x multiplied by derivative of tan x, which is secant square x whole divided by tan x whole square. Alright students, so this is it. We have found the derivative of fx using quotient rule. Now we can simplify it even a bit further if it is required or if it is in the demand of question. But for now we can leave it till here. So this is going to be the f dash x. Now second question is also based on quotient rule. Why? Because here also we have been given the function f of x as quotient of two functions g of x and h of x. So let's see the solution part. We will write f dash x as, in denominator we are going to get square of sin x, and in numerator we will have sin x multiplied by derivative of this function. So we are going to write x raised to the power 5 minus cos x dash and minus x raised to the power 5 minus cos x multiplied by derivative of sin x. So far so good. Now we can write it down as sin x, and here we will have to use the difference rule of two functions. So this will be derivative of x raised to the power 5, which is 5 times x raised to the power 4, minus derivative of cos x is minus sin x, so this becomes plus sin x minus x raised to the power 5 minus cos x multiplied by derivative of sin x, which is cos x, and this is whole divided by sin x square. So we can further write it down as 5x raised to the power 4 multiplied by sin x plus sin square x minus x raised to the power 5 into cos x plus cos square x whole divided by sin square x. Now you can club these two terms, sin square x plus cos square x, in order to get 1 because it is the identity. So we can have 5 x raised to the power 4 sin x minus x raised to the power 5 cos x plus 1 whole divided by sin square x. So this is it. We are done with finding the f dash of the given function, and this is f dash x. Alright students, I hope you people are able to apply the quotient rule in determining the derivative of functions. We will continue in our next session. Till then, keep studying and take care. See you again. Thank you.